So today is our final lesson on C4, predicting and identifying chemical products. We're going to look at a summary of the different elements and groups we've gone through, and then we're going to look at some exam questions. So we've looked at 4 groups on the periodic table in a lot of detail. Group 1, the alkali metals. Group 0, the noble gases. Group 7, the halogens. And last lesson we looked at the transition metals. So these are the flashcards I made previously. You've seen a lot of these already. I'm going to run through them, see what we can remember about each of the groups. So first of all, the alkali metals are group 1. They have 1 electron in the outer energy level. That means they are going to react. They are, of course, metals. Most obvious, but you get marks for saying it in the exam sometimes. Okay, what did this symbol mean? Meant that they were reactive, and again we know they're reactive because they've got to lose that 1 electron in order to become stable, so they'll want to react with something in order to lose it. Now this symbol here, what did it mean? Well, when we added water they became alkalis. So when you add water they become alkalis, and alkali using universal indicator is going to be the purple colour. Okay, what did this symbol mean? It meant that the alkali metals were easy to cut. Now, some of them were easier. They got easier to cut as we came down the group, didn't they? But they are much easier to cut than the average metal. If you think of normal metals, the transitions like iron or gold, these are easy to cut. You can cut them with a knife. What did this symbol mean? Well, it meant that they were not dense. Okay, they were not dense. They have a low density. They float on water, don't they? And finally, you needed to know that they had a low melting point. They are solids at room temperature, but they have low melting points compared to the average metal. Group 0 then were the noble gases. What do we know about them? Well, first of all, we knew that they were non-metals. On the far right-hand side of the periodic table, non-metals. We know that they have a full outer shell. And we know therefore they are unreactive. They don't need to react because they are already full of electrons. They don't need any more, they don't need to give away any more, so they're not going to react with anything. We know that they are colourless gases, and we know some of the uses of the noble gases. So helium is often used in balloons because it is lighter than air, it's less dense than air, and so it floats. We looked at neon and neon lights and the different colours using neon, argon and krypton. We looked at argon in particular, but krypton and xenon also for light bulbs, and also argon in arc welding in order to stop oxygen getting near the sparks and causing an explosion. And lastly, we knew that radon at the bottom of this group was radioactive. We then looked at the halogens, group 7, with 7 electrons in the outer energy level. I told you you need to know by heart the colour trend as you go down the group. It gets darker, but you do better to remember the exact colours. Fluorine is yellow, chlorine is green, bromine is this orangey red, iodine is a grey solid that becomes a purple vapour or a gas, and astatine is black. We know that the halogens are non-metals. They are reactive because they have 7 electrons in the outer energy level. They need 1 more to become stable. They are poisonous and they have a low melting point. This symbol here meant that they were diatomic, which meant they always went round in pairs. So you'd never just find F, you'd find F2. There'd never just be 1 chlorine, it would be Cl2. I put this in just to help you remember that all the halogens are going to gain 1 electron when they react, so they would have an ion of a -1 charge. So it'd always be F -1, Cl -1, Br -1, so on. In general, we use a halogen for cleaning products. Specifically, chlorine tends to be in bleach. We also use chlorine to make hydrochloric acid. And also we find chlorine in PVC window frames. That stands for polyvinyl chloride. Finally, the exam board love this one, talking about iodine being used to sterilise or to clean wounds. So chlorine, bromine, iodine, fluorine, they're all used for sterilising things. Chlorine is used for sterilising water, but iodine is used particularly in surgery to clean the wounds to clean the body before they start to cut it open. The transition metals then are what we traditionally think of as being metals. So they conduct electricity, they conduct heat energy, they are lustrous, which means shiny, they're dense compared to other solids, they're strong, they're malleable, which means if you hit them with a hammer, they are able to be you're able to change their shape. They form coloured compounds often. They're ductile, which means they can be made into wires, and they are used as catalysts, which means they speed up a reaction without being used up. We talked about reactivity then. When we looked at metals, you can see our symbol there for metal. When it was easy to lose electrons and therefore make a positive ion, it became more reactive. So the easier it was to lose electrons, they became more reactive. With non-metals, it was the opposite way around. So when it was easier to gain electrons, they became more reactive. So it was all about how easy it was to become stable. And you can see here I've included the reactivity series. Now I would point out here that I have included, if I can just have a quick look here, you can see here I've included carbon, which is not a metal, and also hydrogen, which is also not a metal, but they are extremely useful when we talk about displacement reactions in Unit 6. So if you're learning the reactivity series, it's well worth remembering where they appear. When we looked at displacement reactions, well, first of all, we talked about displacement, meaning we move something from one place to another. So I've used the symbol here to represent displacement reactions. The two rules we had, that if there was going to be a reaction, the more reactive element was on its own at the start. Now that would apply to a metal or a halogen. And if there was no reaction, then the less reactive element was on its own at the start. We used these examples and we said, look at the element on its own, don't look at the compound when you're trying to figure out how reactive things are. And the more ticks that you've got, the more reactions that have taken place here, the more reactive that metal is. We use this example here as a displacement reaction, and we said a more reactive element will displace a less reactive element. So hopefully that all kind of feels very familiar. That's the kind of, you can see I've tried to pull out the essential points there from the unit we've been talking about. It's not everything, but you can imagine if you're trying to revise for an exam, these flashcards would give you a jumping off point. They would give you little bits of information that would hopefully set you off talking about other things. So let's look at some exam questions then. These are straight off the OCR exam board question papers. This is a foundation question. It says chlorine and iodine are two elements in group 7. So we're looking at group 7 of the periodic table. Both chlorine and iodine have many uses. Okay, so I'm suspecting this question is about uses. Write about some of the uses of chlorine and iodine. Some of the uses about chlorine and iodine. So we're going to be specific here. Now there are 3 marks. Now that would suggest I need to say 3 things. I need to say at least one thing about chlorine. I need to say at least one thing about iodine. And I need to say at least one other thing about one of them. So what am I trying to remember? Well, this is what I'm trying to remember here. Here's my halogens, my group 7, uses of chlorine. Well, I can see here uses of chlorine here. I've got bleach, I've got making hydrochloric acid, and I've got making PVC. Now, if you just said making windows, you're not going to get any marks, are you? You've got to be specific, making PVC. And iodine in particular, I told you they love this question about iodine being used to sterilize wounds during surgery. And if I bring up the answers there, so I might pick 2 of the chlorines and 1 of the iodine. You can see here there's lots of things you could have said for a mark, but they're looking for at least one thing to do with iodine, one thing to do with chlorine, and then one other thing.